An energy balance for biosystem. Module 12, Carbon Balance and Storage. Segment 1, Introduction. Is Lily from School of Life Sciences and Technology, Institute Teknologi Bandung. In this module, we will discuss about the introduction, mathematical models, and carbon storage in trees and wood products. And for the first segment, we will continue to the introduction. Many of the Earth's natural processes are cyclic. The circulation of water between ocean, atmosphere, and continent is a familiar example. And another is the transformation and movement of carbon-containing compound, for which the immediately obvious elements are the photosynthetic generation by plants of carbohydrates from carbon dioxide. Such cycles are termed biogeochemical cycles. The term is most commonly used to refer to global cycle of the life element. For example, such as carbon, oxygen, nitrogen, sulfur, and also phosphorus. But its use is extended as well to regional cycles and to other elements or components. The study of biogeochemical cycle then is the study of the transformation and transport of substance in the Earth systems. In most cases, the cycles link biotic subsystems to abiotic ones, and of particular current interest is the effect of human-caused disturbance on the natural cycles. A major disturbance in the carbon cycle, for example, is the continuous injection of carbon, mainly as carbon dioxide, into the atmosphere by the burning of fossil fuels. A schematic representation. The transport of substance in biogeochemical system is commonly depicted graphically by means of flow sheets or flowcharts, and the number of boxes in a schematic representation is indicative of the level of detail to which an analysis will be subjected or for which information is available. The list detailed for global carbon, for example, consists of only 3 compartments, that is for land, oceans, and the atmosphere, as we can see in the next figure. In the figure 1, 3-compartment representation of a biogeochemical cycle. M represent the inventory, and F are flows or flux. The amount of the substance of interest, represented by M in this figure, in each compartment have unit of mass or moles, and the exchange rates or flow, usually we called as flux, in the ecosystem literature, represented by F in this figure and have units of mass or moles per unit of time. Figure 2, 4-compartment representation of a biogeochemical cycle. In this figure, it presents a similar flowchart with a slightly higher level of detail. This representation recognizes that there may be a significant difference between concentration near the ocean surface and those in the deeper ocean layers. For the next segment, we will discuss about the mathematical model. Until then, I'm Lily from Institute Teknologi Bandung.